Hello, I'm Eric Snodgrass, and thank you for watching today's in-depth ag forecast brought to you by Nutrien Ag Solutions. We're going to start today's video by looking at the NOAA's National Centers for Environmental Information website on their billion-dollar weather and climate disasters. So you can find this by just Googling billion-dollar weather disasters. So let's be the top hit, I'm sure of it. When you get here, slide on down to the big infographic that shows the 2021 billion-dollar disasters. We had 18 of them through the month of October, so this does not include any weather events we had in November or December. More than likely, when they finish assessing it, the December 10th severe weather outbreak in the Mid-South, the December 15th severe weather event in the Midwest, and then the fires we saw here in Colorado on December the 30th will likely be added to this map, producing 21 separate events during that year. When you get to this site, just look around. It's great information here. I encourage you to slide down to the next graphic, which shows you since 1980 all of the years and how each month accumulated cost. Just something to note here, you notice that most of them have a sizable jump between July and November. This is because of hurricane season, and historically hurricanes could take the top spots in the most costly U.S. natural disasters. But I'm going to come back to that event that I mentioned in Colorado that happened last Thursday. And let's talk about the setup for it. So this is the year-to-date precipitation for Denver, Colorado. And what's interesting is 93.32% of normal precipitation is what they ended up getting. But it was the timing of that precipitation that was critical to understanding the setup for the fire. And this is what I mean. See this blue dashed line? That would be the average rate of accumulation of precip. And what you've got here is that through spring and early summer, that was when they were accumulating a lot compared to average. In fact, at some points, they were 160% above average. But right here at the end of July, that event right there was the last time in Denver, in the surrounding area, that more than 1/4 of an inch of precipitation was recorded. And they just went flatline on their precipitation since then. And drought reintroduced into this area after being alleviated in spring and summer. Now what's important about this is that all of this early season moisture led to a lot of vegetation growth, and all this dryness at the end of the season meant that it dried out quickly. In fact, much of this area in and around Denver also had not yet measured snow in the cold season here of 2021. In fact, none throughout the month of December until the very end. What ended up occurring there was this. We had a very strong, what we call downslope wind event, which are common along the front range of the Rockies. But this one, as the flow came over, hit speeds between 60 and 115 miles an hour. The humidity levels were below 10%, and given the dry vegetation, when that fire began, it spread very, very quickly. We got some pictures of it here from space. This is from NASA's satellite called MODIS. It's on the Aqua platform. Caught a mid-afternoon view of what that smoke looked like here. Now what I want to illustrate about this event, just some of the meteorology of it, was the fact that you could see in this cloud field, do you see how there almost appears to be a wave-like motion in the shadow of that smoke? I'd like to talk to you about that because it's a very interesting meteorological event. You see, when the flow comes over the mountains and then comes right down here into the front range, it has a very long way by which it descends and compressionally warms and gets quite dry. When it hits the ground, it often rebounds into what we call a hydraulic jump. Looking at flow over a dam is a good way to kind of visualize it. You see this bounce happening right here? Well, we saw some great footage here taken by a few people that kind of illustrate this. And the first video I'd like to show you from Twitter is from Chris Holder. I'm just going to expand his view here of this time-lapse video he took. Now you can see the flow, the strong winds, all of a sudden rebounding here. In fact, it was producing cumulus cloud, little lenticular cloud there. And as the flow bounced like this, that's our hydraulic jump, it actually went and did this again and again on down the way. So while these fires were moving so fast, in fact, by just looking at some video footage, I was calculating that they spread at about 0.2 acres per second. This fire also experienced a very unique meteorological event, again, called the hydraulic jump. Another great view was taken by Mike Nelson. Great time-lapse video here. He sent this to National Weather Service at Boulder. From the side, now do you see that wave action I mentioned? And the standing clouds sitting on top of them here, just a beautiful view of this incredible and devastating event here taken in time lapse. So I just wanted to share that with you today. After this occurred, the temperatures dropped off substantially. In fact, we measured overnight low temperatures in the single digits, and we saw the first of a couple of big winter storms that spread through the plains in the Midwest. So the first snow of the year came at the very end of the year in this part of Colorado and blanketed everything in white following the devastating fires. But that spread snow through parts of Nebraska, Kansas, Iowa, Missouri, Illinois, all the way into Michigan. And then we watched again as another system came out of the Mid-South, producing very hazardous driving conditions here, and quickly today moved out here through Virginia and into out into the Atlantic Ocean. And that's where I want to start. If you take a look right here at the end of this satellite animation, that's the first big winter storm there that's come across the East Coast. And you can see as I bring it in here towards sunset, the snow in the background right in through here, and it did come back into this part of Tennessee and Kentucky as well. We saw severe weather to the south of this early this morning in parts of North Carolina, some very strong storms. But as you look at this animation, you see a couple of other neat things. You can see the snow swath still in place here, stretching into the Midwest and upper Midwest. That's underneath those clouds. You can also see the extent of the cold air. See these cloud streets down here in the Gulf of Mexico? That's occurring because cold air has advanced all the way there. We have some clearing along the coast, and then the ocean is moderating the air mass, bringing in it to saturation and making these clouds. It's a beautiful thing, but if you ever see this, that's a clear sign of some cold air advection. Our next system is just pummeling the Pacific Northwest, and we're expecting the Cascades to pick up another possibly 5 to 7 feet of snow on this. But we need to be discussing where all of this is going, because there's been some major changes from what we saw in the month of December. So what we saw in December was very frequent, powerful, large ridges setting above the Aleutian Islands. Some of these actually were up to 5 to 6 standard deviations above the mean. We then dove into deeper troughs into the west, anchored around a deep area of cold weather that was stationed here in the Canadian prairie. And despite not having a strong subtropical jet stream, in fact almost none, we still brought plenty of precipitation into California. At times the ridge that sat over the Mid-South moved east. In fact, when it moved east, we opened up the Gulf of Mexico for the severe weather event that hit here on the 10th. When it moved east again, we opened it up on the 15th to give us the severe weather event in the Midwest. But overall, this kept much of the South, the Midwest, the Mid-South, into the East very mild this past December. Now, the question is, the pattern's breaking down away from this over the next 10 to 15 days. Does it come back? That's what I want to ask. Because when we look back on the month of December, this is looking at precipitation ranks by climate district. We saw drought expand in the southern plains into parts of the Midwest. We saw it here. Even though the system this morning brought great precipitation to the Mid-Atlantic and North Carolina, this is an area that needs more. Meanwhile, the West, the upper Midwest, the northern plains, and into the Ohio River Valley all had very wet Decembers. So first question is, how well did the models forecast it? We'll take a look at this pattern and then look back at the beginning of the month. The forecast released on December 2nd did very well with predicting this precipitation, the dryness in the southern plains, the active Ohio and Tennessee Valley, and the dryness here that stretches from the southeast to parts of the Mid-Atlantic. I got to be honest, grading this, the model did a fantastic job with December. But in December, we had a very, very strong signal from the tropics. We're going to come back to that in a second. First, we have 3 different areas in the Sierra Nevada mountains that we measure a collection of weather stations for precipitation. And looking at the northern Sierra, I just want to bring this to your attention. 30.2 is the liquid equivalent on precipitation so far. That almost meets what they had in the entire year of 2019 into 2020, and we've gone way past 2020 to 2021 already by 6.2 inches. We're following these very wet years here, 82, 83, 16, 17. Yet, the events of 82, 83, and 16, 17, those were big El Nino years. So does this continue? We're going to ask that question as well. Soil moisture. This is an area we've been very concerned about. And despite some snow coming through here, remember, snow does not have much liquid equivalent, in terms of water in it. So it's not going to be long-term corrective on the precipitation problems here. But this southern plains drought is one I've been concerned about for months now, because we look at the drought monitor and see how much it's changed. That's an area that over the last 3 months has continued to expand in drought. Will this continue? Will we see relief here? And what about the West, which has seen some really great improvement in the drought situation? Let's get to an answer to all of that. I think that answer is going to begin with the diagnosis of the tropics. Because over here in what we call Nino Region 4, that's out here, okay, we've seen the trade winds, which were once very strong, back off. and the waters have started to warm in this area. What this is doing is this is now giving us a much more what we call east-focused La Nina event, because in through this region, our water temperatures have either been maintained or even slightly cooled, especially right over here in what we call Nina region 1+2. Keep that in mind, okay? The second component of this, which I'll come back to in a few moments, is the very cold water we still have in the Gulf of Alaska. That's going to be critical to the jet stream pattern that we're going to be forecasting here in the next few minutes. You see, those changes in the tropics are leading to some shifts in the MJO. The MJO was very strongly into phase 6 at the beginning of December, and then much of the rest of December was strongly in phase 7. And we remember why it was here, because of all of the subsidence in the Indian Ocean over phase 3. But look at the forecast. Most models take it back toward null space, which is here. Rather than letting it stay out at high amplitude moving counterclockwise around the diagram, it collapses. That means that we're no longer getting such strong and defined signals from the tropics as we had been. And that's going to be critical, because remember me showing you these maps throughout much of December? We saw big stripes of blue meeting big stripes of red. That means that the trade winds were meeting those westerlies. You now don't see that much, do you? There could be times where we get pulses of trade winds, but this is no longer the very well-organized trade wind system we saw on the tip of that La Nina working together with the MJO. So what does that mean? This is going to remove kind of some of our confidence in long-range prediction. So what have we been noticing? I told you that La Nina was reaching a peak, right? Here's some evidence of it. Looking at zonal angular momentum, that's the westward flow of the atmosphere, we've seen an increase since mid-December in this area. That's right in the tropics. That would indicate that we're now starting to get a better sense of that flow heading back toward the west. From the west toward the east. Still no sense of a subtropical jet stream coming out of the North Pacific. But we have to ask ourselves, how does all this interact up here in the mid-latitudes? That's a question we got to get to, because this is where we expect the flow to be by early next week. Now, if you compare this to what I showed you had been happening, take a look. This is where we were. Big ridge here with a deep trough there. The forecast now, let me go back to it here, there it is, develops a trough over the Aleutian Islands, a ridge that comes up over the Rocky Mountains and then dives into a trough here over parts of the Canadian Maritime. The problem is, flow like this does not produce wet conditions along the west coast. It produces upper level convergence and therefore subsidence that comes into a broad sector of the upper Midwest, the Northern Plains, getting over into the mid-Atlantic. All the action is always downstream of the trough, so it's here, and it's here. And as a result, this is going to give us a drier look as we work our way toward the middle of the month. But I want to know, how long does this hang on? So I come back to my original question. What's the influence of this colder water here, and does it regain its strength in keeping more troughs into the west coast? Well, to answer that, let's go take a look here. We know right now that our La Nina is pushing up against South America, over in that region, which I told you to watch out for, Nina 1+2. That's the east-focused La Nina. Historically, that gives us an active January pattern in through here and also here. We tend to be drier in the southern plains, drier along the Gulf Coast, and drier in California compared to average. Now, why does it do that? Well, whenever we see that pattern, let's shrink this up so you can see it here. There we go. Whenever we have a January La Nina pushing against that 1.2 or 1+2 region, ridging tends to reform where it was in December. Ridging tends to reform down here in the south, and the flow comes around and ejects just like that. Hence the active Ohio River Valley storm track and the active snows in the Intermountain West and cold air anchored in the Canadian Prairie. Now, I think the models have bit into this because the long-range forecast for January 15th through February 15th, in fact, let's just expand this. There we go. Looks like that. Can you see it? Now the ridge is back in place. See the drier conditions here? We're wetter coming into this region. Systems come out here in the Tennessee and Ohio Valley and move into the northeast. That is what I would expect to see redeveloping past mid-month if La Nina truly has a grip on this. But I think La Nina has lost some of its grip on this pattern, which is why I'm telling you that my long-range forecast right now, I am not confident in it at all because of this. I also wouldn't look at a temperature map like this one and assume that it's going to look like this throughout much of mid-January to mid-February. We will see temperatures moderating at times in the west and through the Canadian prairie. There will be overall a warm bias throughout much of the south if that ridge reforms in this area. But this is what the current model forecast looks like for mid-January to mid-February. So that's what we're looking at in terms of the longer term. Now, let's come back and discuss the near term, because our multi-model analysis will tell us a lot what to look out for the next week. First things first, our winter storm that was here over the mid-Atlantic is already out. It moved very quickly today, and behind it some higher pressure comes in. But the west coast is reloading, and in both models, the European on the right, the GFS on the left, our systems pulling into the northwest are going to be adding a lot of snow, extremely windy conditions, and coastal flooding. So while we go into a quieter Tuesday east of the Rockies, you're going to have to watch for systems ejecting here by the time we get to Tuesday night and Wednesday morning. Both models by early Wednesday morning, bring a system through the northern plains into Minnesota and Wisconsin. See it in both. And as the snow wraps up into that system, we will see on the back side of this, look how tightly spaced those isobars are. Very, very strong northern winds. And that's going to give us conditions of blowing snow and very hazardous weather. Well, that system very quickly moves into Ontario and into Quebec. And behind it, we have our next wave coming again off of a deeper low that moved through the Pacific Northwest coming out of Colorado. Where are we in time? This is 6 a.m. on Thursday Central Time. Now, the models do not agree on this. I want you to watch them separately. European first. Keep your eyes over here. The European model opens up to Gulf moisture. It then digs a low right here into where the Ohio and the Missouri and the Mississippi all meet. And then it pulls this low through Tennessee and Kentucky, over the Appalachian Mountains, into the mid-Atlantic, and then brings snow into coastal New England. See that? So that system again started here, and then it really invigorated and developed as it moved up toward the northeast. Now, bring your attention over to the GFS. Let's go back to 6 a.m. on Thursday morning. There's the wave. But the GFS, as this system pulls through here, has too high of atmospheric pressure. No good return on moisture. The low doesn't develop, and as a result, by Friday morning, when there's a full-blown winter storm system here hitting the Appalachian Mountains of Virginia and West Virginia, the GFS has nothing. And this is just 90 hours out from right now. This is Friday morning. And as it pulls this through the weekend, shoves whatever kind of low there's going to be off the coast, brings in cold air behind it, but no big New England event. Now, what surprises me is the difference in the two models up to this point, and then this. By getting into Friday night, into Saturday morning, both models come back into alignment. There's an area of high pressure that comes in here. Return flow brings in moisture back into this area, strong southerly winds. It's going to feed into a little clipper system here. See, it's in the same position. And as I go through Saturday midday, Saturday afternoon and evening, and into the overnight hours, they both open up a sector here where along this front, fed by the high pressure cell on the eastern side, we're going to have showers and storms in this area and snow up in Ontario. See, it's in both models there. Very interesting weekend progression, how the models come back into alignment after missing on the system that's Thursday through Friday. So we've gone out a week now. Let's go take a look at the snowfall forecast first. European model. This already fell today. Heavy snows in through this area. We then see a clipper. Remember the clipper that comes here by midweek over Wisconsin. So 2 to 4 inches in this area. Then Thursday into Friday, the next system comes out of the Rockies, comes right down here into the Mid-South, possibly putting down some heavier snow, 4, maybe 5 inches of snow here in this part of Kentucky, Tennessee, and into West Virginia. And then that system moves right up into New England and dumps a bunch of snow there. If I let this go all the way out to, let's just take it all the way out 1 week, this is what the model suggests in terms of total snowfall from now till next Monday morning. This is the GFS. Notice the difference in this area into New England. Major differences overall in snowfall in that region because of the model's difference in the timing and amplitude of that next system. But in the west, it is going to snow. Take a look at this. This is total accumulated snow from the European model. This is raw model data. But you could see that the Sierra Nevada over this next 7-day time period could pick up between 5 and 7 feet of snow. Big snows for the northern and central Rockies. We're going to keep piling the snow up, which is desperately needed in this area. This has been a great start to the season. We don't want to see big ridges slowing this down anytime soon. Now, on the liquid side of it, just want to point out regions that are going to stay drier. Four corner states, Southern California, Texas, Oklahoma. This stripe into the Midwest and the plains. That's going to miss the action in the next week. Week 2 looks like this. By day 10, the flow, remember, trough here, ridge, dives into a trough. This is convergent flow. That's no good for precip. This is not strong onshore flow. That's drier too. And that's why the models looking out there at week 2 are drier in through here compared to average and there. But I don't think this lasts for long. And here's my reasoning. If we look going from the 14th to the 15th, 16th, 17th, and let's just stop it out here at the 18th. See how the heights are beginning to recover here? That's that ridge possibly starting to gain some strength here, like we expect with this La Nina going east focused back south of the Aleutian Islands. That then could give us a much more active mid-month right here from the Midwest through the Tennessee Valley, from the southeast into the northeast. That's when I expect this area to go back overactive, mid-month, okay? From there, let's talk temperatures and wrap this one up. December was extremely warm except for the northern plains in the west. The places that you see the number 1 in, that's now the warmest December on record, and they go back to 1893. A lot of climate reporting districts showing up very warm. Now, as of late, we had a big front that came through, and looking at the temperatures now on Monday evening compared to Sunday evening, we're 20 to 40 degrees colder behind the front. But look at the warm-up that's already taken place here coming out into the plains. Some places are 40 degrees warmer than they were on Sunday evening because of that downslope flow and compressional warming. Well, the temperature pattern is quite volatile moving forward. We already saw Monday's highs. Let's see what happens on Tuesday. Still much above average temperatures in the midsection of the country. But look at the cold air stationed here that's going to come down again behind that system on Wednesday, curling up over the Great Lakes. So we're talking temperatures 20 to 40 degrees colder than average here in the northern plains, getting back into Montana. And that cold air comes out on Thursday into Friday as that next system comes snaking right in through here. Remember that one from Colorado through Tennessee and Kentucky. But as we get into the weekend, moderation behind it. That's the high pressure coming in behind this, warming it back up. But this region is going to get hit a few times in the next 7 days with really cold air. But what about beyond that? The long-range models are washing out the signal. I do expect more mild conditions south compared to average, and there tends to be more colder air in place here. But this is the question mark. How volatile is the temperature pattern in there? And if that ridge really does open up, do we get this much warmth in the Canadian prairie? Or is this too far to the east? This is what I am still researching and trying to understand by looking at all the forecast models and the historical data. We've got a lot of uncertainty in this temperature pattern. If I could be certain about one thing, it's the polar vortex. I was a bit off at the end of December forecasting this. While we saw the polar vortex forecast to be stretched as it is at the beginning of January, it's not connecting up with any sort of a disruption that could influence the troposphere. Notice this. The strength of the polar vortex forecast to be above average. It's got to go way down here before we see a disruption. And going out there, out the next week to next, 7, 8, 9, 10 days, it retreats back over the Arctic, stays strong, and stays kind of as a connected system without breaking off into any certain lobes or any disruptions. So the polar vortex is not yet a part of our winter temperature picture for much of North America, but it possibly could become the end of January or February. We'll watch it and keep reporting back to you. Appreciate you giving me some time off over the Christmas, New Year's break. I'm back on my normal cadence of videos, so I'll talk to you again on Thursday. Thanks.